So thanks very much to everybody for coming today for the latest in our presentations from our Defence and Military Analysis programme. Obviously unmanned systems are increasingly important in modern warfare, and indeed in this year's edition of the Military Balance they were the subject of an essay which I commend to you. My colleague Ben Barry, Senior Fellow for Land Warfare, is going to take the issue on today with the help of lots of pictures, I believe. Ben, I think, well known to many of you already, a wide-ranging career in the British Army, and his last assignment as a brigadier there was to review the lessons of the Iraq War. So without further ado, over to you, Ben, on unmanned systems.
Some of you will recognise the phrase "the rise of the machines" as the title of the third Terminator film. I'm not going to mention killer cyborgs coming from the future with cod Californian and Austrian accents, but we are going to cover autonomous systems right at the end. This is also the third time I've given a talk on this subject, and each time I found there have been new developments that have certainly broadened my understanding, but also raised interesting questions. So the media has paid a lot of attention to the proliferation of unmanned aerial vehicles, UAVs, particularly strikes conducted by armed drones. That's very much the popular image. Far less attention has been paid to a similar proliferation of unmanned ground vehicles, UGVs, and some armies are now remotely operating existing armoured vehicles. Now, I believe these systems are all going to have great utility beyond the withdrawal of NATO combat troops from Afghanistan. Although the vast majority of UAVs and UGVs are currently unarmed, there are no technical barriers to weaponising such systems. And current developments in robotics are going to have important military implications as well. So I'm going to break my talk up into three parts. Part one, I'm going to talk about where we are now, where we've got to with UAV and UGV capabilities. Secondly, I'm going to suggest where these capabilities and robotic capabilities are going in the future, including how advances in civilian applications and civilian technology are likely to increase the potential for wider and more ambitious use of unmanned systems. And then my third part is going to be so what, some of the important implications and questions that are yet to be answered. Starting with UAVs and their contribution to land operations. Of course, much media coverage focuses on drone strikes, but out of the estimated 10,000 UAVs that have been procured by the US military, only a few are Predators and Reapers, and most of these are not armed. And the drone strikes in Somalia, Yemen and Pakistan seem to be carried out by the CIA, not the US Army and the US Air Force. What the media have paid less attention to is the thousands of UAVs that have been procured over the last decade to support land operations. And this is because of the unanticipated challenges posed by insurgents in both Iraq and Afghanistan. The US Army and the US Marine Corps rapidly acquired large numbers of tactical UAVs, usually operating under control of formations, units, down to company level, used in a multiplicity of roles including surveillance, base and convoy protection, and providing an eye in the sky for troops on the ground. These have proven invaluable. And special forces and intelligence organisations have used them to provide an unblinking eye for constant surveillance of insurgents, a practice increasingly adopted by conventional forces. The US Army alone now has an inventory of 5 different types of UAV, from the large Grey Eagle, something that looks like a Predator but is about half the size, to the 2-kilogram hand-launched Raven that you see here. These developments have been mirrored by most of the armies that deployed to Iraq and Afghanistan. Most of these UAVs are owned by armies, some are owned by air forces and operated by air forces, and in some cases contractors wholly or partially operate the aircraft. Over the last couple of years in Afghanistan, we've seen 2 interesting innovations. One is the US Marines using a remote-controlled helicopter, the KMAX, to deliver supplies to isolated bases. At the other end of the spectrum, this is Black Hornet, an example of very small UAVs fielded at the lowest tactical levels This, for example, is a picture of the system being used by the UK Brigade Reconnaissance Force in Afghanistan. It's the smallest system that I know to be in service. It weighs 16 grams. It's only an inch wide, and it's been deployed as a surveillance and force protection aid right down to a low tactical level. What we're also seeing is armoured vehicles being used as motherships for UAVs and UGVs. For example, the British Army has a route opening detachment capability known as Talisman, and this includes a mastiff armoured vehicle, you can see it in the background there, that carries both UGVs and micro UAVs, this is called the T-Hawk, for examining suspicious objects as part of clearing routes. Now, as well as all that, as well as the use of UAVs for surveillance and observation, and as well as arming UAVs with missiles and bombs, armed forces and defence manufacturers have also studied the concept of loitering munitions. And this is an example of one. It's the Israeli Harop. The best way to think of these is as suicide UAVs or long-endurance guided missiles with a man in the loop. And you can see there Harop, which you could get about 2 of in these rooms, diving onto a target array. And the Israelis were playing with this as far back as 2006. At the opposite end of the spectrum, here's a US system that has been trialled in Afghanistan called Switchblade, which is designed for employment at platoon level. It weighs less than 3 kilograms, and I've seen for myself that between 3 and 5 can actually be carried in a rucksack. It's got a small warhead, not much bigger than a hand grenade, and 30 minutes endurance, but clearly it gives a platoon, a squad or a company a new capability to attack enemy that previously would have escaped detection. Similar systems are being developed elsewhere. We've also seen commercial use of UAVs, and it's proliferating with very little constraint, including law enforcement. Staffordshire Police, for example, use drones against poachers in Cannock Chase. The media, this is a snapshot from a Bangkok 24-hour ruling news station covering the protests in Thailand. Agriculture, several companies in the UK now that are making money doing agricultural surveys for farmers. And hunting, these are some American hog hunters who worked out it was a lot easier to kill hogs if you had a drone with a thermal camera and a laser pointer. And of course, this shouldn't surprise anyone. A state prison in Georgia last autumn being used to deliver mobile phones and tobacco to prisoners in jail. And there are credible reports of attempts by criminals, terrorists and Lebanese Hezbollah to arm drones. But let's turn to unmanned ground vehicles. In the last century, many insurgents and terrorists used improvised explosive devices, IEDs. Armies and police forces reacted by developing explosive ordnance disposal teams, EOD teams, to disarm and neutralise such devices. Initially, they just depended on armoured and protected suits, and casualties were heavy. The British Army led the way by developing the wheelbarrow, a remotely operated UGV to allow inspection and neutralisation of an IED from a safe distance. The first one fielded was based on a lawnmower chassis. The system initially mounted a TV camera, a manipulator claw, and could be fitted with a shotgun to disrupt IEDs. And this revolutionised the work of EOD teams, and the technology was rapidly exported or copied throughout the world. But of course the bombers adapted, seeking to make devices more difficult to neutralise in this way. A favourite trick of the IRA was to place the device on the top floor of a double-decker bus. As a result, UGVs became more sophisticated. Remote control links moved from wire through wireless and radio. Sensors improved, as did the capability of the manipulator claws. And small UGVs were produced in order to reach places inaccessible to larger machines, like the top floor of a double-decker bus. Of course, the Iraq and Afghanistan wars saw many such systems purchased for this by the US coalition and NATO forces, and there was a big pulse of development. For example, in 2004, the US possessed 162 such systems. The next year, nearly 2,000 more systems were fielded and used for a variety of roles. And this is a common use to look around the corner and go and see what's in a house or a building. Small, remotely operated soldier transportable systems, widely used by EOD teams and saved many lives. And as each generation of new EOD systems came into service with US EOD teams, the US Army and Marine Corps had a conscious policy of passing the previous generation UGVs, those that were left, to US battalions to use as they saw fit. By 2010, over 7,000 UGV systems were being used by the US Army and Marine Corps, and by 2012 this had risen to 12,000, and it includes more than 2,500 small man-portable UGVs, such as shown here. And this development has been reflected in many of the armies that deployed to Iraq and Afghanistan. Of course, in Iraq and Afghanistan, some of the UGVs used have been alive, but used as effectively UGVs in a variety of roles, including armed, where the weapon is the dog's teeth, and you can see there a radio pack, a TV camera, to enable the handler to see what the dog's up to. Of course, UGVs can easily be armed, and it is a fact that UGVs are much easier to make than UAVs because ground systems are cheaper, and some of the stresses on them are less, although the environment's much more complicated. And this was a demonstrator that Kinetic in the US fielded about 5 years ago. Fitting UGVs with weapons provides no technical difficulties at all. Israel has developed the Guardian, a UGV designed to patrol its borders and the perimeters of airfields, and it can be armed. Now we've seen a parallel system, a parallel development. Bespoke EOD systems have always been small and have tended to get smaller, but there's been parallel development of full-size, remotely operated vehicles to perform the same function as a manned vehicle without a crew. Now what we see here is the Israeli D9 armoured bulldozer, which is used on Israeli operations into Gaza to clear obstacles. There are a hell of a lot of mines and IEDs they've got to clear. Now this is a very high-risk category, and it wouldn't surprise you that the D9R, you see on the right of this slide, stands for D9 remotely operated through an add-on kit. The British are using the same approach. This is a slide of a Talisman detachment at work in Afghanistan, and the vehicle on the lower right is a remotely operated armoured Land Rover carrying a ground-penetrating radar to detect buried IEDs. But the great thing is, if it fails to detect the buried IED and is blown up, no soldier is killed. The British, actually, the nation that invented the tank, are leading the way in remotely operated armoured vehicles. This is their new Terrier armoured engineer vehicle, which has a similar role to the Israeli armoured bulldozer of breaching obstacles under fire. It's the first armoured vehicle that I know of to have a full drive-by-wire design, and that has allowed it to be designed from the outset to be operated remotely from up to 1,000 metres away by using a gaming-type controller and remote cameras. This is genuinely revolutionary technology and something that British lead on, but the defence media seem to have paid it relatively little attention. Now this illustrates the potential benefits of remotely operating armoured vehicles, but why shouldn't this be taken further? With advances in robotics, operator displays and synthetic environment technology, why do armoured vehicles going into high-risk areas need humans in them at all? Or shouldn't it be possible for one manned armoured vehicle to control another similar armoured vehicle remotely? So let's look at some of the trends for the near future. I think that carrying and using on-board UAVs and UGVs will offer military vehicles new options for seeing round the corner or over the hill, and also for putting up a communications relay. The US Army is busy experimenting with manned-unmanned teaming between helicopters and UAVs, but I'm not aware of any army conducting similar experiments into teaming between UAVs, UGVs and armoured vehicles, although the Singapore Ministry of Defence has announced an aspiration to do so. There are also now sufficient UAVs being sold for civilian applications as to allow this emerging industry to be self-sufficient and survive in its own right after NATO's mission ends in Afghanistan. The technology required for simple small UAVs is not sophisticated. The industrial and financial barriers for entry are low. So we're likely to see the cost of these systems reduce as the potential utility increases. This may make them so cheap as to be expendable on operations and widely employed by the news media. And the news media aren't going to be interested in the operational security of troops manoeuvring on the ground. They'll be after the story. Small UAVs are likely to continue to be difficult to detect, and if detected, difficult to shoot down. There are already a number of UAVs on the market disguised as birds, and this picture here, the top two pictures, are of a UAV disguised as a kite, the hawk that is, that crashed near Quetta, Pakistan 4 years ago. No one's owned up to possessing the UAV. The other picture, which is actually older, is of a Canadian soldier in Afghanistan using something called the Maverick UAV, US produced, which seems to have been designed from the outset to look like a bird. So I think small UAVs are likely to have an enduring utility in land force tactical operations. Now, I've also had credible reports that some small UAVs are capable of perching, that is, landing during a mission, continuing to observe their target, but obviously preserving their battery or fuel life, and then take off again. This, of course, extends their endurance and provides additional tactical options. Research is being conducted on this. For example, US researchers are working on allowing UAVs to recharge themselves by perching on power lines. There's military research being conducted, and indeed civilian research, into small UAV technology, incorporating lessons from the animal kingdom, bird and insect flight, and also swarming behaviour, and improving conventional and unconventional power sources. And that, of course, is what we know about. What we don't know about are black programs going on in the US and elsewhere. I suspect we could therefore see a degree of convergence between the roles of UAVs and UGVs. We're actually seeing convergence of several technologies anyway. Small and low-cost, high-performance sensors, optical sensors, that's being driven by the mobile phone industry. Continuing increases in cheap computing power and ever-improving software. This is what allows those UAVs using multi-rotor helicopters to be flown with little or no operator training. And these technologies are becoming increasingly mature and driven not just by military research, but by commercial R&D. Indeed, I believe that actually if all military R&D on UAVs stopped right now, there'd still be sufficient civilian R&D to keep the industry alive. Now, all the current land UAVs and UGVs are remotely operated by soldiers, although some UAVs have autonomy built in for them, that if they lose communications, they'll fly back to a known point, or even fly back to where they were launched from. But they're not, with that exception, they're not autonomous. Now, this gives the advantage of having a man in the loop, but it depends on the command link, mostly radio, but sometimes wire, for UGVs, being uncontested by the enemy. Now, this has been adequate for Iraq and Afghanistan, but in operations against an enemy with an electronic warfare capability, such radio links are vulnerable to interception and jamming, and indeed attempts to take over the UAV or UGV itself. So giving unmanned systems a degree of autonomy would reduce their dependence on radio command links. It would also allow them to operate at greater range and in hostile electronic environments. It would also reduce the burden on system operators, and it could allow them to operate more than one vehicle at a time. Indeed, all the Israeli UAV manufacturers who are showing their wares at the Singapore Air Show told me that you could buy a command centre that enabled you to operate up to a dozen UAVs at a time with far less than a dozen people. Now, a specific area of considerable research is that of autonomous or near-autonomous civilian vehicles. And this is a picture from The Economist that summarises the current technology that you need to make these systems work. And the technology that allows unmanned operation of aircraft right now is close to allowing unmanned and autonomous operation of cars and trucks on public roads. It's also growing in parallel with technology being fielded to assist drivers, for example, automatic parking. The latest European model of the Ford Focus incorporates this and many other automated systems to to incorporate safety and assist the driver, and it wouldn't take much to put a black box in to make a top-of-the-range, forward-focused, fully autonomous. Manufacturers are working on this hard, including Mercedes-Benz, Nissan, Volvo, Ford, BMW, General Motors, and of course Google, developing prototype autonomous cars, and in some cases trucks, that combine advanced sensors, image processing, and artificial intelligence. Google's cars have clocked over 500,000 kilometres on roads. Now, some experts, including McKinsey, assess that the technology will be sufficiently mature by the early 2020s to allow affordable autonomous cars and trucks to be mass-produced. And this could trigger a revolution in ground transport, regulations and public acceptance permitting. But short of full autonomy, there's also substantial value in systems that assist drivers in steering, braking and collision avoidance to make them more safe. And I wonder if insurance companies are going to start expressing an interest in this. And the potential benefits of these systems include increased safety, reduced CO2 emissions, and more that motorists can do when they've got their hands off the wheel. It could also greatly increase productivity in the trucking industry. And all these potential developments will be widely applicable to military ground vehicles. It could mature very rapidly, this technology, particularly driven by the civilian trucking industry. In military logistics, it could reduce the number of supply trucks that need manned crews, for example, with several trucks slaved to follow a manned vehicle. Or completely unmanned logistic convoys could be used to send supplies through high-risk areas. These are driverless trucks that are big dumper trucks, the giant dumper trucks, already in use in a vast Australian open cast mine owned by Rio Tinto Zinc. The US Army and Marines are both developing what they call an autonomous mobility applique system, basically a kit that you can add on to any vehicle, either to enable it to follow a manned lead vehicle in a convoy or to navigate autonomously via waypoints. And this is a picture of two such trucks being tested just 2 months ago. At the other end of the spectrum, US forces are also trialling load-carrying unmanned ground vehicles that can follow dismounted soldiers carrying much of their load from them. And those could both follow soldiers or navigate autonomously. Now, both remote operation and autonomous technology can also be applied to combat vehicles. For example, a tank platoon that comprised both manned and unmanned tanks. In the longer term, it would allow the design of fielding of completely unmanned full-scale ground vehicles for the full range of land warfare roles, from close combat, armoured engineers to logistic trucks. Reducing or eliminating the crew would reduce the size, weight, fuel consumption and cost, and also allow increased tactical, operational and strategic mobility. And armies would also have the option of accepting lower levels of survivability for unmanned vehicles if they chose, which would further reduce the weight, fuel consumption and cost. Now, the other technology that's maturing is robotics, and this is the sort of current picture of robotics. Over the past several decades, industrial robots have taken on physically difficult, dangerous, dirty or very dull jobs which are easy for humans to get bored with and mess up, such as welding and spray painting. Now, the robots have been expensive, bulky and inflexible, bolted to the floor and fenced off to protect the factory workers. The next decade is likely to see a major increase in the capability of robotic systems, driven by advances in machine vision, artificial intelligence, machine-to-machine communication, sensors and actuators, reducing size and cost. And this technology may come from unexpected places. Those of you who are young enough, or young enough in heart, to own a Microsoft Xbox will know the Kinect sensor, which is a sensor they've designed to enable humans to interact with a computer game by moving their arms and legs around. That sensor, which Microsoft retails now for about £100, is widely used in robotic labs because it's very easily reprogrammed to be a people detector, to enable robots to move round buildings, round factories, and indeed round hospital. And as an example, there's at least one US company that right now has experimental unmanned factory trolleys carrying the hospital laundry around a US hospital. New software can make it much easier to program robots. They can be more compact and adaptable, making it safe to deploy them alongside humans. So it's going to lead to robots substituting for more human labour in more manufacturing tasks, and also in a growing number of service jobs such as cleaning and maintenance. The technology could also enable surgical robots, robotic prostheses, exoskeleton braces for disabled people or elderly people, and there's potentially a big service industry there, with robots helping to care for elderly people, increasingly ageing populations in Western countries and Japan, and there are Japanese countries that are on the case. So we're going to see robotic technology move much further into civilian applications, including medicine, healthcare, and a wide variety of service industries such as cleaning and maintenance, illustrated by an announcement earlier this year by the British inventor James Dyson. These countries going to explore developing a range of robots for domestic applications. Of course, many of these civilian applications will also apply to the military. For example, a wide variety of logistic tasks could be assisted by robotic technology, and the US Army is actively exploring this in a drive to reduce the number of people in deployed brigade combat teams from about 4,000 to 3,000. Now, some of these can be foreseen. Others will be new applications identified by soldiers and officers as they see the potential value on the battlefield, whether it's a complete military bespoke application or it's taking a civilian application into the military environment. So what does all this mean? Well, this is the US Defense Advanced Research Agency, DARPA, their competition to develop robots that can replicate human roles in disaster relief. There's a whole load of text there, which isn't necessary to read, but you can see the 7 tasks. Driving to a site, walking across rough terrain, removing debris, opening doors, climbing an indoor industrial ladder for 20 feet, cutting through a wall, carrying and connecting a fire hose, and locating and closed leaking valve. It's a sort of Fukushima scenario. And it was won by Team Shaft. Funny old thing, Team Shaft is owned by Google, and they've withdrawn from the next stage of the challenge, apparently confident that they can now get ahead of their competitors and start developing a full system to go to the market first. And there are big technology companies that are making big financial bets on unmanned, autonomous and robotic technology. Amazon, looking at robots to better automate its warehouses and working on the idea of a delivery drone. Google has recently been on a spending spree of companies with impressive credentials in unmanned vehicles, autonomous systems and robotics. And there must be good reason for this. Now, increasing autonomy of the full range of military ground vehicles, and indeed increasing autonomy in air vehicles and some of the applications of robotics, are going to carry with it a large number of second-order issues, including safety, moral, ethical and legal problems. But if the considerable potential of this technology, robotic, autonomous, unmanned, is exploited in civilian sectors, many of these issues are going to be easier for the military to handle. And indeed, it will be quite hard to argue that a civilian technology should not be transferred over to the military, particularly where it helps save lives. And while some Western nations may have some scruples about completely autonomous unmanned systems, particularly if they're armed, other nations, non-Western nations, may have no such inhibitions. This and the requirement to operate unmanned systems against opponents that can attack electronic command links is likely to result in increasing degrees of autonomy in unmanned systems worldwide. So where's all this going? Let me try and predict the developments we're likely to see over the next decade or so. This is dangerous stuff, but this is my best judgment at the moment. I think what we're going to see is unmanned and robotic systems, both armed and unarmed, proliferating. Now, high technology, expensive systems will probably remain exclusive to wealthy, high technology states. But states with less wealth and lower levels of technology and non-state actors are going to have access to simple, cheaper systems and in great number. And great numbers of simple, cheaper systems may be an asymmetric edge in some areas. We're going to see them used in a wide variety of military and security roles. Levels of human input and control is going to vary. In many cases, they will be used in a complementary or collaborative role, partnered with humans or with manned vehicles. But for some roles, they could probably fully replace manned systems. But they won't be immune from logistic, maintenance and training constraints and costs. A particular utility is that fielding unmanned force elements may allow greater generation of mass, of sheer volume of military capability. Let's take an example of tanks. If unmanned tanks were a third cheaper than conventional crewed vehicles, a country that could, say, afford 100 conventional tanks could trade that in for 60 conventional tanks and 60 unmanned tanks, increasing its total tank fleet size to 120 for the same cost in hardware, not to mention the reduced cost of the crew and the reduced risk to the crew on operations. Now, the ethical, moral and legal issues will be important. Development of deadly autonomous systems alarms many people, and not just those who've watched too many Terminator movies. There is a campaign to stop killer robots led by human rights organisations, and I think many of their arguments are quite credible, but I do differ with them in some of the judgments they make, particularly in terms of the applicability of the law of armed conflict, but we could explore that afterwards. The Convention on certain conventional weapons, which has previously been responsible for the international agreement to ban laser blinding weapons, is busy discussing a ban on arming autonomous systems, much along the agenda proposed by the campaign to stop killer robots. But in other areas of defence and in other contexts, partly or fully autonomous defensive systems are already in service, driven by the need to respond to attacks very quickly. For example, in air and missile defence. You wouldn't be able to defend, if you had a missile defence system using current technology, you wouldn't be able to defend successfully against a big salvo of ballistic missiles without handing the decision-making and the targeting over to the computers and the network. And autonomous systems can be programmed with strict rules of engagement, which they cannot break. And they cannot break in response to fear, fatigue, hatred of the enemy, or the fact that the enemy killed some captured prisoners last week. Now, current UK thinking appears to be that the decision to engage a target will require human oversight, but other nations may not feel so constrained. For example, a state that sought to confront US and Western forces might choose to invest in large numbers of armed autonomous systems as part of an asymmetric approach. For example, if China, as part of its anti-access and aerial denial strategy, chose to engage in swarms of armed UAVs that were designed to target US warships, that would probably be extremely effective part of their tactical repertoire. It would also be wholly consistent with the laws of armed conflict. It's highly likely that non-state actors, such as criminals, terrorists and insurgents, will use these capabilities for reconnaissance, surveillance and violent effect. Those small UAVs and driverless cars or trucks will be easy to weaponise for criminal, terrorist or insurgent purposes, although it would be possible to build some countermeasures into the system. Now, it may be that commentators in the West and politicians and the public in the West are happy to accept robots and drones for defensive roles, such as detecting IEDs, but are troubled by their offensive roles. But wars can't be won just by defence. And public, political and media attitudes might change if an adversary inflicted US, UK or NATO casualties using such technology. Why, they might ask, were enemy armed UAVs or UGVs not being countered by our own? That's it.
Ben, thank you very much indeed. Absolutely fascinating, and it really opens up the possibilities for change, not only in warfare but actually in ordinary life.
Yeah.
So I'll open it up straight away to questions. If you could just say who you are when you ask a question.
I'm Zahir Azmi. Thank you. It was a very good talk. I must appreciate you for that. And my question is related to the last part of your presentation about the trends. Now, I think with this type of technology, the human cost of waging war may decrease, but may increase the proclivity to wage a war? And how will the states and the international law deal with this with such a challenge, if you consider it one? And likewise, what will we do with the unemployed human resource once robots in civilian technologies or civilian sector takes over? Though it may be compensated by low population growth rates, but how do you think will it ultimately affect the society?
Thanks.
There's two questions there, Zahir, really. This is a point made by the Campaign Against Killer Robots, that it's going to make war easier if the country that would initiate the war is going to suffer less human casualties. Well, that might be the case if they had a large superiority in this capability. But this capability can be countered, including by developing your own capability to do this, both offensively and to a certain extent to deter someone attacking you in this way. But I think people are right to be concerned about it, certainly. The social and economic disruption that the introduction of much more capable robots into industry and also into agriculture, I think that's the reason that McKinsey last year, in an excellent report on 15 disruptive technologies that they thought were going to have strategically disrupting effects in both the civilian and military sector and the state and private sector, they selected robotics and autonomous vehicles as one of them. And it's not a new challenge, because historically this has been a major problem. What has happened usually is that as a new technology has effectively closed down one line of civilian employment, if it increases overall national affluence, that's been a good thing, provided the affluence has been reasonably shared. And secondly, historically, luckily, other economic technologies have come on that have allowed people to be displaced into other areas, although not necessarily the same people because of differing educational requirements. I think this is going to be a really difficult one, but I also think, let's take an example in the UK. There's a real political issue in the UK about care of the elderly and seriously infirm. You might recall there have been recent headline stories about carers, being limited to 15-minute visits to very infirm old people. Well, if actually 70% of what the human carer could do can actually be done by a robotic system, is it not worth investing in those robotic systems to enable the human carers to be more efficiently employed? But I think these are going to be really difficult issues, and on the geo-economic level you have to wonder whether these economic and social issues are going to be seen very differently in, say, Europe as they will be seen in the US, as they will be seen in the growing economies of the Asia Pacific, or indeed in Pakistan.
Thanks. And gentlemen, the second row there.
Thank you very much. Andreas Bink, University of Reading. You mentioned that the idea that we make war cheaper or more easy conducted is contingent on the fact that we have a preponderance in these kind of capabilities. I would note that that's precisely the case as we have employed them so far. Somalia, Yemen, Pakistan, Afghanistan, there's not much of a defense or a counterbalance there. And the danger I see then here is perhaps not only that it is easier to wage war, but it's easier to wage permanent war. To have these countries or these regions of the world in a sense defined as borderlands which need constant patrolling. We can afford to patrol their skies with these weapons. UGVs, we can deploy UGVs in order to interfere rather cheaply without much resistance to this. So parts of the world in much where the conflict is happening these days in much of the countries of our concern, be it failed state or be it states that are collapsing, might very well then become fields in which we in the West, the countries that have these capabilities, wage a form of, if you will, permanent war. I wonder if you could...
It's a fair point. Of course, this is actually where both international law and, to a certain extent, the law of armed conflict is important, because the US interprets both differently to the UK and many European countries. So, for example, under the US interpretation, under some scenarios, retaliation they regard as perfectly legal. For example, the retaliatory strikes against Saddam Hussein conducted in the late 90s after he sent a sort of column into Kurdistan. They also legally have been pretty comfortable with the CIA operating the drones over Pakistan, Yemen, and the Horn of Africa. They, of course, also see things differently because they were on the receiving end of 9/11. Let me just put this another way, though. I personally think that the drone strikes over Pakistan, we're getting to the stage where the disadvantages strategically for the United States seem to be on the tipping point of exceeding the advantages because of the anti-American, anti-Western sentiment they've engendered. But many of those targets that were taken on by drone strikes could have been taken on by a raid of air assault troops or special forces in helicopters. That would have almost certainly have led to increased US casualties. It probably, in many scenarios, having looked at the sort of terrain and having done similar sort of things on exercise myself, could have led to more civilian casualties and collateral damage because of the larger force on the ground. Now, I think your general point about there being a sort of lawless badland internationally right now, in the way, say, half of the American West 200 years ago was was a lawless badland. That's a wider point, but in some cases, I think countries that feel they must strike against imminent threats, the Hellfire missile from the drone is probably more effective and causes less civilian casualties and collateral damage.